Hello, and welcome back to the third video for section 5.2, polynomial functions. All right, so let's just dive right into this. The general form of a polynomial function is written as f of t equals a sub n t to the n plus a sub n minus 1 t to the n minus 1 plus dot 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 a sub 2 t squared plus a 1 to the t plus a 0. So this is a pretty heavy definition, but it's really not so bad once you start working with it. Let's look at an example. An example of a polynomial is f of x equals 25x to the fourth minus 2x cubed plus 3x squared minus 7x plus 10. So let's see what this means in terms of a polynomial. So for one thing, for it to be a polynomial, all the powers, so those are my n's, have to be positive integers. So they can be 0, 1, 2, 3, etc. Right? We need to have positive integers. Number two, we need to have the a sub i's. These are the coefficients. They need to just be real numbers. We don't want any imaginary coefficients right now. Coefficients need to be real numbers. So whole number powers, whole positive whole number powers, real number coefficients. So all these guys are non-examples. So let's see if we can figure out why these guys are not polynomials. Pause the video and look at these three examples and see if you can decide why they're not polynomials. All right, the first one is not a polynomial because this is 3x to the 1/2, right? And 3x to the 1/2 has a 1/2 power. That's not a whole number, right? So that's not a polynomial. This is not a positive power, right? It's negative. And this is not a whole number as well. 3/5 is not a whole number. So you need to have whole numbers that are positive to have a polynomial. So let's go back to the general form. This is polynomials written in order of decreasing degree. That means it goes down 4, 3, 2, 1, 0 powers on the x. If you write it in order of decreasing degree, this first term is called the leading term. Obviously, if you don't put it in order of decreasing degree, anything could be the leading term. So you need to put the highest degree first, and that's going to be the leading term. A sub n is called the leading coefficient. And n is called the degree of the polynomial. That's the highest power. So if we look at our example of f of x up here, the leading term is 25x to the fourth. Okay, that's the leading term, 25x to the fourth. The leading coefficient, that's just the 25. And the degree, that's the 4. And it's really nice because the end behavior of a polynomial is completely based on the leading term. Okay, so whatever that leading term behaves like, that's what the whole polynomial behaves like. So for example, in this one, f of x equals 25x to the fourth minus 2x cubed plus 3x squared minus 7x plus 10. It's going to behave like the power function. That should be like f of x equals 25x to the fourth. 25x to the fourth. That's what it's going to behave like. So this is a power function with a positive leading coefficient, even term, so it's going to behave like x squared. And we know that whole polynomial is going to behave like x squared. All right, so let's go through and let's practice describing a polynomial. Why don't you guys try to answer these questions, and then pause the video, try to answer these questions, and we'll go back over them again. All right, did you get this figured out? Let's go over this together. What is the leading term? 32v to the sixth. What is the leading coefficient? 32. What is the degree of this polynomial? Oh no, I made a terrible mistake. What did I do wrong? I didn't put this in order of decreasing degree. So let's go back and get this right. Did you guys fall for the same trick that I fell for? Let's put this in order of decreasing degree. Minus 2, this is higher than 6. Minus 2v to the 7th plus 32v to the 6th plus 8v minus 3. Now it's in order of decreasing degree. 7, 6, 1, and 0. Now what's the leading term? Minus 2v to the 7th. Minus 2 is the leading coefficient. And the degree of the polynomial is 7. So what kind of a polynomial is this? It's going to be negative because it's got a leading coefficient of -2, and it's odd because the degree is 7. So what is this one going to look like? Odd, negative. It's going to look like minus x cubed, right? So as, what was my variable in this one? V goes to minus, or let's go to infinity first. As V goes to infinity, my function, what is the name of this function? T of V goes to minus infinity. And as V goes to minus infinity, T of V is going to go up to infinity. Because it behave just like minus x cubed, right? That's what we're thinking about here, minus x cubed. And I know my x cubed drawings aren't great, but they give you the basic idea. All right, that wasn't so bad. Let's talk about turning points and intercepts of polynomial functions. And really, the point of knowing these rules is, again, so if you're using a graphing utility, lots of times you plug it in, it pulls up a graph. You might not see all the things you need to see, and you need to adjust the window and zoom. So you need to know what you're expecting to see. All right, so turning points are local maximums and local minimums. So if I just draw like a quick polynomial up here like this, right, these are my turning points. Any of these local maxes and mins. So a polynomial will have at most n minus 1 turning points where n is the degree, okay? So let's think about our toolkit functions, see if we can make sense of this rule. If we think about x squared, right, it has 1 turning point. The degree is 2, and it has 1 turning point. If we think about x cubed, x cubed is kind of weird. It really only has this one weird turning point in the middle here. But if we think about like x cubed with some sort of a qualifier in front, it looks a little bit more like this, right? Something x cubed. And we can see that it has this one could have 2 turning points. This one even doesn't even have 1, right? It mostly has 1 flat spot. So this one is degree 3, and it has sort of 0 turning points. But we could make a little bit more extreme cubic looking function, n equals 3, and it could have 2 turning points. All right, so it's always going to have one, at most, one less than the degree of turning points. Let's talk about horizontal intercepts. Remember, this is where it's crossing the x-axis. Any polynomial will have at most n horizontal intercepts, where n is the degree of the polynomial. Let's think about our favorite functions again. If we think about even just x squared, well, x squared could look like this, right? And would have 2 nice horizontal intercepts. So that could have 2. But it could also look exactly like just regular x squared, where it comes down and it exactly touches, and it only has 1 horizontal intercept. Or we could have an x squared that looks like this, right, and has no horizontal intercepts. So again, at most, the number of the degree of intercepts. And finally, vertical intercepts. All polynomials have exactly 1 vertical intercept. And that vertical intercept is going to be when you plug in 0 for x, right? Exactly where it crosses the y-axis. And it can only cross once because they're all functions. All right, let's do one last example here. Let's think about the function g of x equals 2x cubed minus 6x squared minus 20x. Let's figure out the leading term, leading coefficient, degree of the polynomial, and behavior. What are the max amounts of turning points and horizontal intercepts, and what do we think and find the vertical intercept? All right, first of all, let's check if it's in order of decreasing degree, and it is, so that's good. So the leading term is 2x cubed. And the leading coefficient, such a long word, isn't it? Coefficient is 2. And the degree is 3. And the end behavior, well, it's going to behave like x cubed, right? It's going to behave like x cubed. It's positive and odd. So as x goes to infinity, g of x goes to infinity. As x goes to minus infinity, g of x goes to minus infinity, just like x cubed. What is the max amount of turning points? Max turning points. What was our rule for turning points? Right? What was our rule for turning points? Let's go back up and look. It's if the polynomial is degree n, it will have at most n minus 1 turning points. So our polynomial is degree 3, so we'll have at most 3 minus 1. That's supposed to be a 1. 3 minus 1 equals 2 max. Maximum number of turning points is 2. What about horizontal intercepts? Remember that rule? Horizontal intercepts, that's equal to the degree, right? So it's going to have at most 3 horizontal intercepts and vertical intercepts. Sept, I should say, there's only one. Well, we find that by finding g at x equal to 0. So that's 2 times 0 cubed minus 6 times 0 squared minus 20 times 0. I can do this all in my head because that's 0. So the vertical intercept is x equals 0, y equals 0, 0, 0, which is actually conveniently also a horizontal intercept. All right, so we found what this function's looking like. We know there's going to be at most 2 turning points. We know there's at most 3 horizontal intercepts. We know it goes through the origin. Once you graph this, let's go ahead and graph this guy, and this is what it looks like. We got this all right. Here's my 1 turning point. Here's my 2nd turning point. Here are my horizontal intercepts and also my vertical intercept. As x went to infinity, the function goes to infinity. As x went to minus infinity, the function went to minus infinity. So we got that all correct. So into section 5.2.